All right, ready to dive into something a little unexpected. We're talking shapes today.
Shapes!
Yep, shapes. You might not think it's the most thrilling subject,
Why?
but trust me, we're looking at this textbook chapter about visualizing solid shapes, and I think it's going to be way cooler than it sounds.
Okay, I'm intrigued. We are surrounded by shapes, right? Everything around us.
Exactly. That's what I find so fascinating is like this hidden language we use to make sense of the world. And speaking of language, the textbook dives right into dimensions, that whole 2D versus 3D thing. What does that actually mean?
Well, imagine you're looking at, say, a drawing of a pizza on a menu.
Okay, I'm with you.
That's two-dimensional, flat. It has length and width. But then you think about the actual pizza, the one you eat.
Now we're talking.
Right. That's three-dimensional.
Uh-huh.
It has that height, that depth, the cheesy, saucy goodness that makes it, well, a solid object.
So it's not just about adding another measurement, it's about transforming the whole experience, right? From a flat image to a real thing.
Exactly. And here's a thought. Even something as thin as a piece of paper technically has a third dimension. It might be tiny, but it's there.
Whoa, you just blew my mind. I never thought of a piece of paper as having depth.
It's easy to overlook. Now let's talk about some of those familiar 3D shapes. The textbook mentions cubes, spheres, cones, cylinders. Imagine things like a box of tissues, a basketball, an ice cream cone, even those majestic pyramids in Egypt.
Ooh, ice cream. But yes, I see what you mean. These shapes really are everywhere. Once you start noticing them, it's like you've unlocked this secret code to understanding how things are designed.
That's a great way to put it. Just like learning a new language, once you know those basic shapes, you can start to see how they combine and create these complex structures around us.
Like the alphabet of the physical world, right?
Precisely. But let's not forget about their two-dimensional counterparts, those flat shapes that come together to actually form these solid wonders.
Which brings us to nets. Now, I'll admit, this part always tripped me up a bit back in school.
Imagine you have a cardboard box, and you carefully unfold it completely flat.
Okay, I can picture that.
That flat layout, that's essentially the box's net.
So it's like we're reverse engineering a box. Each flap on that net would then become one of the box's sides.
Exactly. And that's why understanding nets is so helpful. It allows us to visualize how those 3D shapes we were talking about are actually built from simple 2D shapes that we all know.
The textbook even has this cool challenge where it asks us to build, get this, a tetrahedron.
A what?
A tetrahedron. It's basically a pyramid but with a triangular base, and we're supposed to build it from its net. Talk about a hands-on geometry puzzle.
I like it. Sounds like a fun way to get a feel for these concepts. Speaking of getting hands-on, the textbook then moves into how we can actually draw these 3D shapes on, well, a flat piece of paper.
Okay, now that feels like a magic trick. How on earth do you show depth when you're limited to a flat surface?
Well, one way is to use what's called oblique sketching. Think of it like taking a quick snapshot of the shape, where you're looking at the front face straight on, and then the sides are kind of angled back to give you a sense of depth.
Ah, so it's like those drawings you see in diagrams with the slightly tilted perspective.
You got it. It's great for getting a quick impression of a 3D shape, but if you need precise measurements, that's where isometric sketching comes in.
And that's where those isometric grid paper sheets come in handy, right? The dots arranged in triangles.
Exactly. Those grids help create perfectly angled lines, so you get a much more accurate 3D representation, even though you're still drawing on a 2D surface. It's pretty neat.
It's like a secret code for artists and designers.
Right. The textbook actually shows us a 4x3x3 cuboid drawn using both methods, oblique and isometric. It's really interesting to see how different they look.
I bet. Oblique is like the quick sketch, while isometric is the blueprint, right?
Exactly. You wouldn't want to build, say, a bookshelf based on a quick oblique sketch, would you? You'd want those precise measurements that you get from an isometric drawing.
You've got a point there. Wonky bookshelves are not a good look.
Definitely not. So we've got the basics of drawing these individual shapes, but what about visualizing them, say, stacked on top of each other or arranged in more complex ways?
Ooh, that's a good one. How do our brains even begin to process that?
That's where spatial reasoning comes in.
Spatial reasoning.
Yeah. It's not just about shapes themselves, but about understanding the spatial relationships between objects. The textbook has this fun activity where they show you a stack of cubes from different angles.
Ooh, like a 3D puzzle. I love those.
That's a great way to think about it. And you have to figure out how many cubes are in the whole structure. It can be surprisingly tricky.
Sounds like a good workout for the brain.
It is. And these spatial reasoning skills are crucial for so many things we do, like packing a suitcase efficiently, reading a map, even just rearranging furniture.
Or if you're an architect designing a building, or a surgeon operating on the human body, it's all connected.
Precisely. It's amazing how these seemingly simple concepts of shape and space have such far-reaching implications.
Absolutely. It makes you appreciate the elegance of how things work.
Definitely. So, we've talked about dimensions, different types of sketches, spatial reasoning. It's like we're really starting to unpack this idea of three-dimensionality. But what about looking inside these shapes, beyond their surfaces?
Now we're getting to the really cool part, dissecting things. It reminds me of those cooking shows where they slice open a cake to show the layers inside.
Exactly. It's the same concept, but instead of cake, we're talking about shapes. The textbook calls these cross-sections, and they use the example of slicing a loaf of bread. Picture cutting through that loaf, the shape you see on the cut surface. That's the cross-section.
So if you cut a round loaf, you get a circular cross-section, and a square loaf gives you a square one. Pretty straightforward.
Exactly. But think about it. This idea goes way beyond bread. Imagine medical imaging techniques like CT scans and MRIs. They rely on understanding cross-sections to create images of what's happening inside the human body.
Wow, so you're telling me that understanding the cross-section of a 3D shape is basically like having X-ray vision?
Well, it's a bit more complicated than that.
Yeah, I figured.
But you're definitely on the right track. It highlights how powerful these concepts can be.
That's incredible. It's amazing how these seemingly simple ideas can have such profound applications in the real world.
Exactly. And speaking of seeing things from different perspectives, the textbook also delves into this fascinating world of shadows.
Shadows. Now that's interesting. How do shadows fit into all of this?
Well, a shadow is essentially a two-dimensional projection of a three-dimensional object, right? Created when light is blocked. It's like a glimpse into how our 3D world interacts with 2D surfaces.
That's a cool way to think about it.
The textbook uses the example of shining a flashlight on a cone. Depending on where you shine the light, the shadow changes shape dramatically.
Right. Shine it directly at the cone, you get a triangle, move the light to the side, and suddenly the shadow is stretched out, distorted.
Exactly. It emphasizes how the angle of the light source plays a huge role in shaping how we perceive a 3D object through its 2D shadow.
It's like the shadow is this constantly changing portrait of the object, always influenced by the light. The textbook even challenges us to visualize this with a cube and see how the shadow morphs as we move the light source around.
It's a great way to build those visualization skills. And speaking of perspective, it reminds me of that example with the circular plate and the sun.
Oh, right. The one where the plate's shadow changes throughout the day as the sun moves across the sky.
Exactly. Even though the plate itself doesn't change, its shadow can be anything from a circle to a thin oval, all depending on the sun's position.
So even something as simple as a shadow can reveal a lot about an object's three-dimensionality and how it interacts with light.
Precisely. It's like a subtle dance between geometry and light, which actually leads us to one final crucial aspect of visualizing 3D objects: understanding how they look from different viewpoints.
Okay, so we're not just talking about shadows anymore, but actually changing our own perspective, like walking around an object to see it from all sides.
You got it. Think about looking at a house. A front view might only show you the front door and a couple of windows, but if you walk around to the side, you might see a chimney or a back porch.
And if you could get a bird's eye view from above, you'd see the whole layout, like a blueprint.
Exactly. Each viewpoint gives you a unique piece of information, and it's by combining those viewpoints that we get a complete picture of the object.
It's like piecing together a puzzle. Each view gives you another clue.
And this idea is essential in countless fields. Architects use blueprints with multiple viewpoints to design buildings. Astronomers use it to visualize celestial objects from different angles.
And artists use perspective drawing to create the illusion of depth on a flat canvas.
Exactly. Whether we realize it or not, we're constantly engaging with these concepts of shape, perspective, and visualization in our everyday lives.
It's like this hidden framework that underpins how we experience the world around us. It's really quite amazing when you think about it that way.
It is. It's like we've been speaking this language of shapes our whole lives without even realizing it. And now we're starting to understand the grammar. So as we wrap up this part of our deep dive into the fascinating world of shapes, what are some key takeaways you want our listeners to ponder?
Well, I think the biggest one is just how much we take for granted when it comes to shapes. They're everywhere, but it's only when you start to really see them, to pay attention to their properties and how they interact with each other, that this whole new world of understanding opens up.
I couldn't agree more.
We've talked about dimensions, different sketching techniques, spatial reasoning, even shadows. It's been quite a journey.
It has. And the exciting part is, this is really just the tip of the iceberg. There's so much more to explore when it comes to geometry and how it shapes our understanding of the world around us.
That's a great point. So I'd like to leave our listeners with a little challenge. The next time you're holding a coffee cup or unpacking a box, even just noticing the shadow cast by a tree, take a moment to really appreciate the hidden world of shapes that's at play.
Think about the design of the objects around you, the interplay of light and shadow, the different perspectives you can view things from.
It's like having a superpower, being able to see the hidden structures and patterns all around us.
Exactly. So until next time, keep exploring, keep asking questions, and keep those minds sharp.
We'll be back soon with more fascinating insights. It's incredible. It really makes you appreciate the power of these concepts, even something as simple as a shadow.
Right. It's like this hidden language that we often overlook.
It's like we're constantly surrounded by these visual clues, but we don't always know how to read them.
Precisely. And speaking of visual clues and perspective, the textbook also talks about this really interesting concept of, well, viewpoints. Like how we see a 3D object can change depending on where we are in relation to that object.
Okay, yeah, that makes sense. Like a coffee mug looks very different if you're looking at it from the side versus from above.
Exactly. The textbook actually uses the example of a house. Think about it. If you're standing right in front of a house, you might only see the front door, a couple of windows, maybe a porch.
But then you walk around to the side.
Right. And suddenly you see a chimney, maybe a back door, completely different features that you couldn't see from that initial viewpoint.
And if you were a bird flying overhead.
Exactly. You'd get a top-down view, like a blueprint, showing you the entire layout of the house, the roof, everything.
It's like each viewpoint gives you a new piece of the puzzle.
That's a great way to put it. Each perspective reveals something unique about the object's shape and structure. And it's by combining those different perspectives that we get a complete picture.
And this idea of multiple viewpoints, it's not just some abstract geometry thing, right? I mean, it has real-world applications everywhere.
Absolutely. Think about architects, for example. They rely on blueprints that show a building from all angles, front, side, top, to make sure everything fits together properly.
It's like those blueprints are their way of communicating those different perspectives to the builders.
Precisely. And it's not just architects. Astronomers use this concept to visualize celestial objects, like planets and stars, from different angles to understand their movement and position.
And let's not forget artists. They use perspective in their drawings and paintings to create this illusion of depth on a flat surface. It's incredible what they can do with just a few lines and some clever shading.
It's really quite remarkable. Whether we realize it or not, this understanding of shape, perspective, and visualization, it really is fundamental to how we perceive and interact with the world around us.
It's like this hidden language that we use to make sense of everything.
Exactly. And the more we learn about this language, the more we start to appreciate the elegance and complexity of the world around us.
So, as we wrap up this part of our deep dive, what's the key message you want our listeners to take away from this exploration of shapes and perspectives?
I think the biggest takeaway is that understanding these concepts isn't just about acing a geometry test or impressing your friends with your spatial reasoning skills. It's about developing a deeper appreciation for the way things work, for the beauty and order that underlies even the most seemingly ordinary objects.
I love that. It's about seeing the world with new eyes.
Exactly. It's about recognizing the hidden connections, the patterns, and the elegance that surrounds us every day.
It's like we've been wandering through a museum this whole time, surrounded by these amazing masterpieces of shape and form, but we didn't have the right lens to truly appreciate them.
I love that analogy. It's like we've finally put on those special glasses that reveal the hidden beauty and complexity of everything around us.
And it all starts with understanding those basic building blocks, those fundamental shapes that make up our world.
Exactly. We've talked about dimensions, about different ways to visualize and draw 3D objects, about how our brains perceive spatial relationships.
Yeah, we even touched on the concept of shadows and how they can reveal so much about an object's three-dimensionality.
And of course, we explored the importance of perspective, of seeing things from multiple viewpoints to get a complete picture.
It's amazing how these concepts, they seem kind of abstract when you first hear them, but they really do touch on so many aspects of our lives.
They do. From the way we navigate our surroundings, to the way we design and build things, to the way we experience art and nature, it all comes back to these fundamental principles of shape, space, and perspective.
It's like unlocking a secret code, being able to see those hidden connections everywhere you look.
Exactly. And the best part is, this is just the beginning of the journey. The more you learn about geometry, the more you realize how much there is to discover. It's a lifelong exploration.
And it's an exploration that anyone can embark on, right? You don't have to be a mathematician or an artist to appreciate the beauty and elegance of shapes.
Absolutely not. It's all around us, just waiting to be noticed and appreciated. So for anyone listening who feels inspired to see the world with fresh eyes, my advice is simple. Be curious, ask questions, and never stop exploring.
Beautifully said. And on that note, I think it's time for us to wrap up this fascinating deep dive into the world of shapes.
It's been a pleasure exploring these ideas with you.
Likewise, to all our listeners out there, keep those minds sharp, and we'll see you next time for another exciting adventure into the world of knowledge.